All right, so our last problem. At a certain coffee shop, all the customers buy a cup of coffee. Some also buy a donut. The shop owner believes that the number of cups he sells each day is normally distributed with a mean of 320 and a standard deviation of 20. He also believes that the number of donuts he sells each day is independent of the coffee sales and is normally distributed with a mean of 150 and a standard deviation of 12. The shop is open every day but Sunday. Assuming day-to-day sales are independent, what is the probability he'll sell over 2,000 cups of coffee in a week? So I would do a little table first, probably to kind of like just draw out the mean and standard deviation of these things. So I'm going to do X bar, sigma, and then coffee and donut, and I'm not going to spell it like they did. So 320 cups of coffee on average with a standard deviation of 20. Donuts are 150 with a standard deviation of 12. And this is all per day. So now this is each day. They're open every day but Sunday. So if I wanted to find the mean amount that they sell during the week while they are open, what would I need to do of coffee? Yep, multiply it by 6. So I'll have X bar equals 320 times 6, which gives us 1,920. How do I have to do the standard deviation? Yep, so it'll end up being the square root of 20 squared, which is the variance, and then times 6. And if we do that, we're going to get 48.9 cups. So, it says normal model. So, the mean would be 1920. They want to know what the likelihood that they sell over 2,000 is. So, that would be that area up in there. So I need to find so we can either find the z-score and do it as a completely normal model, or we can use these numbers and just change the mean and standard deviation when we do normal CDF. So I'm going to do it like that. So normal CDF, 2,000 on the low end to 1E99. Then the mean is 1920 and the standard deviation is 48.9. And when I do that, I get 0.05 for that number. So basically, this is the probability here. So there's a 5% chance, basically, that they sell 2,000 cups of coffee in a week. So if he makes a profit of 50 cents on each cup of coffee and 40 cents on each donut, can he reasonably expect to have a day's profit over $300? Explain. So, I'm going to basically take each of these things here and multiply them by the amount of profit that he's going to make to find like how much he can make, and then we'll do the expected value. So for coffee, well, let me do it this way. Just go ahead and set it up. So coffee would be 0.5 times 320, which is 160. Donut is 0.4 times 150, which is 60. Then for the standard deviation, 0.5 times 20 would be $10. And donut 0.4 times 12 is $4.80. So now I can do the expected value, which is to add up these two values here. So the expected value, X bar, is 160 plus 60, which is going to be 220. Sigma is the square root of 10 squared plus 480 squared, well, 4.8 squared, which is going to give me $11.09. So basically each day he should expect to make $220 with a standard deviation of $11.09. So I need to find the z-score, which is what they want to make. So 300 minus the mean of 220 over the standard deviation of 11.09. Which is 7.21. So let's see, normal CDF of, what are we looking for, 300? No, I'm going to do it as the normal. $7.21, 1E99, and then 0 and 1. I think that will work. Let me make sure. Yeah. So this one comes out to be 12 zeros and then a 2. So we're going to just call this 0. It's approximately 0. So it is, I don't even know where to write this. I'm just going to say very unlikely to make profit 300 or more. Need a bigger box. So since I was using expected values, that's why I used the z-score on this one to do it with 0 and 1 versus the other one. I just used the mean and standard deviation that they gave me with the numbers that I was trying to find. So you can do it either way, but this one with the expected value, it's better to do it this way. All right. What's the probability that on any given day he'll sell a donut to more than half of his coffee customers? So basically, we're looking at donut to more than 0.5 of coffee. I'm just going to use D for donut, C for coffee. So D minus 0.5 C is greater than 0. So I'm going to take his average amount of coffee customers and donut customers and plug those numbers in and see what happens. So we'll get 150 minus 0.5 times coffee is 320. Would give us -10. Standard deviation of these things, so this was the mean. Standard deviation is going to be the square root of each of their standard deviations squared, or well, basically we're going to take this but plug in their standard deviations, but we have to square them because we're going to be adding. So donut was 12 squared minus 0.5 times 20 squared. Oh wait, I forgot. We always add when we're doing this, not subtract. I was like, this is going to give me an unreal answer. Go, because you're supposed to add them. So when I do this, I get 18.55. Number seems really high. Hold on. That's right. This is something we have, whenever we're multiplying by a scalar, so like half of the coffee customers, we actually need to multiply this first and then square the whole number. Let me make a note of that here. For scalar multipliers, square the whole thing. So let me redo this now.
Wait, why is that?
It's just like a rule. If you have them, like, so like the coffees, they're saying half the coffee customers, so I need to take that and go ahead and half that, which is just going to be 10 squared. So
it's always going to be like that in this kind of problem?
well, if it's multiplied by a scalar, so like this was like half of the coffee customer, so yes, it would be if it's that situation. That's why I was like, I'm just going to make this note here because that's a confusing rule that I always forget about. So this gives us 15.62. So then we can do our z-score, which is basically we want it to be like 0 or like exactly half, but the mean of that would be negative 10, but we're minus a negative, so plus 10 over the standard deviation, 15.62. So 10 divided by 15.62 is 0.64. So then we'll have normal CDF of 0.64, 2099, and then 0 and 1. Which gives us 0.26. So essentially there's a 26% chance that he will sell a donut to more than half the coffee customers in a day. So this is our probability that we were looking for. And that's it. We're not doing example 11. I usually skip that one anyways, and just for the sake of time, I think it would be better for y'all to just work some out of the book at this point. So let me give you